Can mass timber reduce the carbon footprint of construction? A new method for constructing wooden mid- and high-rise buildings could pave the way for a critical strategy for reducing the construction industry's massive carbon footprint. Although experts in forestry, construction, and climate change disagree on the extent of its benefits, mass timber is a promising replacement for concrete and steel, both of which contribute 5% of global carbon emissions. Buildings account for 40% of total emissions, and architects are hailing this new green building technique as the next great disruption to the construction industry. What exactly is mass timber? Buildings must use wood products, typically engineered panels, as the primary load-bearing structure in order to be considered mass timber. Mass timber is a broader building style that can be used for mid- and high-rise buildings in addition to wood-framed houses. Builders can use a variety of woods, often from small trees, to construct a strong structure in which the wood grain is stacked perpendicularly to fortify the structure. Because of its versatility in wood types, mass timber projects can be sourced in a sustainable manner by utilizing small and diseased trees that are cleared to manage forests and prevent wildfires. It also means that sourcing can be localized, reducing carbon emissions during transportation even further. Despite the fact that deforestation is a major concern around the world, forests in the United States are managed in a sustainable manner. A collaboration between the mass timber and sustainable forestry industries has the potential to support this emerging construction industry niche, which would have far-reaching implications for combating climate change. The advantages of mass timber. The primary advantage of using wood instead of concrete and steel is that carbon emissions are reduced. Because concrete and steel emit greenhouse gases during production and transportation, using locally sourced wood is thought to reduce the overall carbon footprint of building construction. In addition to lowering emissions, wooden panels, posts, and beams sequester carbon. The wooden panels are lighter and stronger than steel, and they could potentially be made fireproof. Because wood interiors are naturally warming, they promote energy efficiency and lower heating bills. Wooden interiors are becoming increasingly popular, particularly in Europe and the Northwest United States, as an aesthetically pleasing and trendy look. Say a typical steel and concrete building emits 2,000 metric tons of CO2, with mass timber, you can easily invert and sequester 2,000 tons of CO2, architect Andrew Ruff explained. For instance, the materials are less susceptible to changes in weather during construction, and the construction process itself is quicker and quieter, making for happy neighbors during construction. Rather than contributing to climate change, you are mitigating it. When compared to conventional concrete and steel, the construction process also offers a number of advantages. Fourth-generation Washingtonian lumberman Russ Vacan asserted that mass timber is the future. It holds great promise as affordable housing and even improves homeowners' health and well-being, according to several studies of wood's biophilic qualities. It is at least 25% faster to build with and requires 75% fewer workers on the active deck. It comes from renewable forests that, in many cases, need thinning to reduce the risk of wildfire and disease. Does mass timber represent a fad? The advantages of mass timber, or at least how much this method can affect climate change, are not universally accepted. In Oregon, sawmills were reopened as a result of its trendiness, and loggers were put back to work. John Tallberth, president of the Center for Sustainable Economy in Portland, stated, "We want to dispel the myth that mass timber is somehow connected to some kind of environmental benefit. Most researchers agree that there is simply not enough data to make such large claims about the benefits of mass timber, nor enough data to prove it false. For example, the carbon sequestration calculations need to take into account the transportation, manufacturing and logging of all wood materials when making comparisons to concrete and steel emissions. Furthermore, the wooden beams would need to be reused beyond the predicted life of the building itself in order for the carbon sequestration benefits to be realized, because the decomposition of wood also emits carbon dioxide. Living up to sustainability promises. Forestry experts contend that the rapid growth in popularity of the mass timber industry must be married with sustainable forestry initiatives, such as certification standards, to ensure that the harvest, manufacturing and transportation processes are environmentally friendly, transparent and included in more accurate cost-benefit analyses.